Hey guys, the last time on 2.1, we talked about the derivative and the slope of the graph, and I told you guys that the slope of the graph at the point equals to the slope of the tangent line at that point, right? So that's the key point there. And we also know how to figure out the derivative by using the definition of the derivative. And the last piece of information that I taught you guys from 2.1 was about differentiability and continuity, right? So if we have differentiability, it means that the function has to be continuous, but if you have like a continuous function at the beginning, it doesn't mean that your function has to be differentiable. Okay, so watch out for that. Okay, and for 2.2, let's talk about some rules of differentiation. So last time we learned how to find the derivative by using definition of limit, right? This time we're gonna learn how to find the limit by using the rules. Okay, so before we get into that, let's review a little bit about the definition of the derivative. So the derivative of f at x is given by the slope, or like the derivative of f, and that can be calculated by using the definition of like quotient formula and combined with the limit idea. Okay, and a function is differentiable if x if its derivative exists at x, right? Else it's not going to be differentiable. Okay, so today we can learn some rules in here. We're going to learn 4 rules in here, because as you like experience from the last section, the process of finding the quotient like formula and then taking the limit of that is really tedious. It's like like hard and long, and it involves a lot of like algebra skill, and is like complicated. So today I'm going to show you guys a new way to find the derivative, okay? And we're going to go through like the 4 rules in the next second, okay? So now let me talk about the first objective of today, the constant rule, like the first rule among like the 4 rules that I mentioned from the last page. So the constant rule is say that the derivative of any constant is equal to 0, okay? So for example, the derivative of like negative 0.4 in here, I'm gonna like say that is 0, because if you look at this number in here, it doesn't have any variable, right? It doesn't have an x, it doesn't have any letter next to it, it's just a number. And derivative of any number, like any number in here that you want to plug it in, like it doesn't matter if you have a mixed number, a fraction, a decimal, or a whole number, even 0, they all will end up being 0 for when we take the derivative of it. Okay, so this is what it means by the constant rule. Okay, and what does it mean, right? Like the constant rule in here, it implies that the slope of the horizontal line, it equals to 0, right? Just imagine like you have like a horizontal line here, right? What is the slope of it? We know that m in here is equal to 0, because the equation in here is like y equal to c, or if you want to pick for like a certain number, let's say this is like 4. Okay, so let's say that like this line in here, the equation of it is like y equals to 4, right? And if you want, you can rewrite it as 0 x plus 4 equals to y, right? And then from here we know that the slope in here, m equal to 0, right? So the constant rule in here tells us that the derivative of a number, any number, equal to 0. That means that the slope of any horizontal line is also 0. Okay, another like interpretation of constant rules, it says that the tangent line to a constant function is the function itself. Okay, so that's another like way so that we can understand it. Okay, so there's like 1, 2, 3, 4, 5, 6 of them in here. Let me just do like 3 of them, and then I'm gonna give you guys like the other 3 to do. Okay, so let me finish A, B, and C, and then you guys will have to do D, E, and F. Okay, so these are all your part, D, E, F. Okay, so for my part, I did part A already, and a 0. For the second one, I have to take the derivative of y, a variable, but then y equals to like a number, right? So we don't have the variable anymore. If you want, you can rewrite it as dx, like the derivative of 24 divided by 5, and because 24 divided by 5 in here, this one is a number, the derivative has to be 0. Okay, similarly for c in here, because 0 equals to y, or like y equals to 0 in here, the derivative of a number, the derivative of 0 in here would be 0 itself. Okay, so the final answer for all a, b, c, they all are 0. And it's like easier to understand because on this page we only have the constant rule, right? Like no matter what number you have for to take the derivative, you're always going to end up with a 0, okay? So just a heads up, the answer for D, E, and F, they should also be 0, right? And then just make sure you understand why, okay? Like just make sure you know the reason why they become 0 when we take the derivative of them, okay? Now, next page, other rules. So I told you from the beginning that we're gonna have 4 rules, right? The constant rule is like the easiest one in there. That's why I said it first. The other rules, the other 3 rules are similar to each other. So we're gonna have the simple power rule. If you want, you can call it the power rule. I'm calling it simple because for now we haven't talked about like chain rule and everything yet, but in the next sections we will talk about the chain rule, okay? And then there we're gonna learn the general power rule, okay? So for now, for 2.2, let's stick with the simple version of the power rule, okay? So what does it say? It says that if we have like derivative of x to the n in here, we're gonna bring out the n, and then we're gonna minus the power by 1, okay? And it's coming from, like, if you want to know the reason, it's coming from like the practice of doing, you know, like FOIL, of taking like x plus delta x to the second power, third power, fourth power, and so on, and in general, n power, right? So each of the time you're gonna get, say for the first one, you're gonna get like x plus delta x times x plus delta x, and then you're gonna FOIL them in. So, you know, like first, inner, outer, last. Long process, you're gonna end up with this result, right? Similarly, we have like 3 groups of x plus delta x in here, but because it's to the cube, like it's to the power of 3, then we're gonna have to multiply it by itself 3 times, right? So then after all of that, you're gonna get this result in here, okay? And let me finish writing this one down, okay? And then similar procedure for this one, you're gonna multiply x plus delta x by itself n times, okay? And you're gonna end up having this result in here. And if you notice, these, like the later on terms, are the one that has delta x squared, like 2 delta x's as a factor, okay? So honestly, you don't even have to understand this at all because I'm not gonna test you on that. That's why I like jump right directly into the rules earlier. If you want, just remember the rules at least, okay? You don't have to remember the derivation of it because I'm not going to ask you to derive it anyhow. So don't worry about it, okay? So as long as you remember the formulas in here, then you save. So let me, you know, like highlight it out so then to show that you have to remember it, okay? So for a quick example in here, let's imagine that we have this one is a typo. It's meant to be x to the power of 10. Not like, you know, like x to the first power and then 0. That's weird. Just imagine we have like a function, right? X to the power of 10, right? And then we want to take the derivative of it. The derivative, by the way, we're going to do like the prime thingy in there, like a comma, but like hanging in the air. We call it prime. Like that thingy, we call it prime, okay? And we only use it for derivative, okay? So derivative. Okay, just in case you guys don't know what it is. Like the name for it, like we decide to call it in English by prime to represent the derivative of something, okay? So now think about this function right here. We want to take the derivative of it. Well, first of all, we're gonna bring out this power. So let me highlight it in, I don't know, like pink. We're gonna bring down this power to the front, okay? And then we're gonna subtract that power down by 1. So we're gonna get 10 minus 1, which is 9 on the new exponent in here, okay? Simple enough, right? Like just 2 steps. Bring the power in front and then minus the power by 1 to get a new power. Okay, and then for another example in here, just imagine if I'm giving you something like, you know, like a fraction like this. Well, before we can take the derivative of it, first of all, let's rewrite it as like x to the something, right? Because this formula in here is only applied to the case of x to the power of something. It doesn't apply to 1 divided by x to the power of something, right? And to do that, well, because notice that the x is on the bottom, right? So the power of it, when you bring it up top, it has to be negate. Okay, so it's going to be like x to the negative 10, and this procedure has nothing to do with the derivative. It's just the way that we rewrite fractions into negative power, okay? And now that we have this as like x to the something, as just like what we have in the formula, well, what we're going to do is that we're going to bring down the power in front, So the negative 10 will go up front, and then the new power would be negative 10 minus 1, which is negative 11. Okay? And again, I really hated to have like, like negative exponent or, like fractional exponent. That's why last step in here, don't stop right here, okay? Like, don't call this one the answer because it's not the good answer to me. Whenever you have a negative power, make sure you turn it back into positive number by switching it, okay? So the negative 10 in here, it has nothing to do with like the negative 11 as for the power. So the negative 10 will stay on top. X to the negative 11, because it has a negative exponent, that means it's going to be on the bottom now. And then to compromise with that, we're going to make the power positive. That means we're going to get x to the 11 on the bottom, okay? And this is the answer for the second problem. And then this is the answer for this problem. This is the answer for that problem. Okay? Now, let's talk about the third rule that we have for like today. We have the constant multiple rule, okay? This one to me is pretty simple. All you have to do is that whatever like number you have like in front of the x or in front of the like the group that you were talking about, you just kind of like bring it out front first. Like you set it apart from the variable and then you take the derivative of the variable, okay? So this one in here, you have to use the power rule. That's why the power rule comes first, and then the constant multiple rule comes second. And here, let me give you guys a quick example, okay? But before that, let me just highlight this out, so then you guys will have it down in front of you, like in terms of like homework and assessment, okay? So just imagine if I give you some problem like like negative 2x, right? And I'm asking you to find the derivative of negative 2x. What are you gonna do? Well, negative 2x, let's divide out into two things, right? Like we have a negative 2 in here as like a number part, and the x in here, it is the variable part, right? The negative 2 in here, we're gonna put it in front because it's just a number, right? It's like separate from x. So we're gonna put it in front. We don't do anything to it. We just kind of like separate it out, okay? And for the x part, now we're gonna take the derivative of it. That's why it has like a little prime in here, to show us that we're gonna take the derivative of only x now, and we're gonna like set aside the number, which is negative 2 in here, okay? And x in here is actually x to the first power, right? And we're gonna use the simple power in here. First of all, we put the power in front, which is 1, and then up here we're gonna do 1 minus 1, which is 0. So we're gonna get 1 times x to the 0. And if you remember from the past, anything to the power of 0 is 1, right? So we're gonna get 1 times 1, which is 1, right? So x to the first power, x prime, the derivative of x is 1, okay? And that's why in here, I should have like some more steps in here. I'm gonna get something like, like negative 2 times 1, and this one coming from like the derivative of x, and then negative 2 times 1, it equals to negative 2, and this is the final answer for this problem in here, okay? And lastly, we have the sum and the different rules. Okay, so for the sum in here, it tells you that like if you take the derivative of the sum, then you can take the derivative of each of the functions separately, okay? Same thing goes for the difference. If you take the derivative of a difference, then you can take the derivative of each of the terms and then subtract them, okay? For example, if I'm asking you to take the derivative of a group of a sum of x plus x squared, then you're going to split it out into the first term, which is x, the second term, x squared, and then in between we still have the operation of addition, right? And then the derivative of x is just like from before. We know that it's 1 right here. Derivative of x squared by the simple power rule in here, we're going to bring out a 2. And then the new power will be 2 minus 1 equals to 1, right? And then, okay, so we're going to get something like, here, you know what? Let me write down. So the derivative of x squared equals to 2x, 2 minus 1 in here. And that equals to 2x to the first power, but then x to the first power will be just x, right? So then that's how we have the 2x in here. And these are the final answer of this problem, okay? And if you notice, sometimes I use parentheses in here, and sometimes I use like bracket in here. And the truth is, it doesn't really matter whether you use a bracket or parentheses, they're all the same thing, okay? So I'm not going to be like too judgy if you put like parentheses, brackets on this one, so don't worry too much about that, okay? And now let's talk about some practice. How can we apply it into problems, right? That's why I dedicate like the home page for this one. I want you guys to get used to this one because you guys gonna see it on the quiz and on the test, okay? So make sure you pay attention to this one because it's, you know, like it's not hard, but it takes a lot of practice to get used to it, okay? Like I'm gonna be honest. At the beginning, I didn't understand anything about this one because there are like 4 rules, and then, you know, like anything that more than 2 is, you know, just a lot to me. But then at the end, after I did like, I don't know, like 20 or 30 problems of this style, I just got used to it, okay? So if you want, just do these problems from the worksheets, and then also do the one on the homework problems. And then if it's not enough for you and then you still not like fast with doing this one, like doing this type of problem, make sure you do more style, like do more problems of this style. And you can find these problems either on Google if you type like, you know, like find the derivative, or if you want, you can stick with a textbook in there. There are like plenty of problems in there that you can try, you can practice, or you can even ask me to give you some problems to practice it, okay? But make sure you do it because you're gonna see it in the next quiz and also on the first exam, okay? Right, so now let me talk about example in here. So first of all, for my example, well, I'm gonna have to use the sum in here, the sum formula. The sum rule in here, they call it the rule. So the sum rule in here. So first of all, I'm gonna split it out, right, into like x squared plus and then the 1, right? For each of them, I'm gonna take the derivative of them, right? The derivative of 2x. Like I said, I kept like get used to this already, so I'm just gonna do it like really quick. It's 2x, right? We pull the 2 out front, and then the new power in here will be 1, but then x to the first power will be just x. That's why we only have just 2x, right? For the second one, for the 1 in here, because 1 in here is a constant, right? It's a number. It doesn't have any variable attached to it. So we're gonna apply the constant rule in here, and then the derivative of 1 or any number, it would equal to 0. And at the end, if you add them, you're gonna get 2x, and this is it. Okay. For the second one, well, we're gonna do the same thing. Again, we're gonna apply the sum rule, so it's gonna look like negative 3x squared, derivative, and then plus 6 by itself, and then derivative. Okay. The first one is kept like a little bit harder to deal with in terms that you have to use the power rule, but the second term, as you can see, it will go to 0 right away, right? Because 6 in here is a number, and just like the last time, 6 is just, you know, like a constant, and it doesn't have any variable attached to 6 in here, so it just turned out to be 0 when we take the derivative of it, okay? For the second one, well, first of all, we have to apply the constant, what is it, I'm trying to remember it, the constant multiple rule in there. There we go. The constant multiple rule in here. So it means that, well, we're going to set aside a negative 3, and then we're going to focus on taking the derivative of just the variable part, which is x squared, right? And then the derivative of 2x again is, the derivative of x squared again is 2x, right? So I'm going to go ahead and do it like this, and at the end, my answer in here is negative 6x. Okay? So next one, I'm having derivative of x to the 4 over 3 minus 9. So this one, right off the bat, I'm going to use a difference rule. So I'm going to have to do the derivative of x to the 4/3 in here separately from, like the 9 here. And obviously, as you can see, the 9 here is just a constant. So again, this one will go to 0. So we don't even have to worry about it. And next up, I'm going to apply the simple power rule, right? So that means I'm gonna bring the power up front, and then on the variable part, I'm gonna take 4/3 minus 1. Let me do 4/3 minus 1 into my calculator, and it gives me 1/3, right? And I told you guys I really hated to see, like power in fraction form. Whenever you see like power in fraction form like this, make sure you put it back into, like the square form. That will be more like, like nicer to look at. In the test and in the assessment, I would appreciate if you can go further more and then just give me something like 4/3 and then cube root of x, because power of 1/3 in here is actually the cube root, right? Power of 1/2 in here is a square root. Power of 1/4 in here is a 4th root, and so on, right? Anyways, this one is the answer. However, if you want to stop it here and call this one the answer, I'm just gonna take out, I don't know, like 0.5 or like 1 point from your work. But yeah, just keep in mind that this one will be like a nicer version of the answer, okay? So next one, we have this one, and obviously, like you guys can see, we're gonna split them out. We're gonna use a difference rule in here, so we're gonna get negative 6x 4/3 derivative, and then minus 9 derivative, right? Like this one, again, is a constant, so fast forward to 0. The second part, it equals to negative 6 because it's a constant again, so we're gonna pull it out. Like, we're not gonna do anything to the negative 6, but we're gonna have to focus on taking the derivative of 4 to the 4/3. Okay? And what do we know? We know that the derivative of x to the 4/3 in here, it equals to, just like before, 4 over 3 and then cubed of x, right? So if you put everything into the calculator, you're gonna do negative 6 times 4 divided by 3. And if you don't want to use your calculator like me right now, I'm gonna do it mentally really quick. So negative 6 is negative 6 over 1, right? And then from here we can cancel the 3 with the 6, so this is 1 and this is a 2, right? So together, like if you multiply everything together, you're gonna get a negative 8 and then cubed of x. And this is the final answer. Okay, and let me change the color before I keep, like writing all over the place. So let's do 5 in here. Okay, so we have to take the derivative of this. So same deal, we're gonna split them out. Derivative of 1 over x and then minus the derivative of 1, right? And then 1 is the number, so ignore it because it's just gonna turn out to be 0 anyways. Just like what I did in the last page, because this one is 1 over x, right? It's not like x to the something. So we have to convert it to x to the something first, and 1 over x is x to the negative 1. We take the derivative of it, and then that means that we're gonna bring out a power, and then we're gonna minus 1 onto the old power to get a new one. So rewrite it, we're gonna get negative 1 up top, and then x2 on the bottom, and then to compromise with the position, swapping, the negative 2 will become a positive 2, okay? And this is the final answer of ours, okay? And now for the next one, let me change it into blue. We get 5 over x and then minus 2, right? So right off that, you guys can see that the 2 in here will be disappear when we take the derivative of it because it's just a constant, so it will be like 0, right? And then in short, 5 over x in here, we can rewrite it as 5 times x to the negative 1, and then we take the derivative of it. We're gonna set the 5 aside, and then we're gonna have to focus on the derivative of x to the negative 1, right? And if we go ahead and we do that, well, just like earlier, we know that the derivative of x to the negative 1 is equals to negative 1 divided by x squared, right? So putting everything together, the answer in here is negative 5 over x squared. And we're done. Okay, next one, let me put it in green. Okay, so this is longer, of course. We have to apply the difference rule in here and also the sum rule in here, right? So same deal, we're gonna go ahead and apply derivative to each of the terms in here, and we're gonna get 3 of them, right? So we're gonna do x derivative and then minus 1 over x to the 4th derivative and then plus 5 derivative, right? And right off that, 5 in here is like a number, a constant, so that's why it's gonna be 0. The derivative of x is 1. The derivative of 1 divided by negative 4, 1 divided by x to the 4th power, we don't know what that is because, again, it doesn't look like the form of, like x to the something. That's why we're going to have to rewrite it as x to the negative 4. Okay, and then we're going to take the derivative of that. And then 1 is just 1. I'm going to rewrite it. The derivative of x to the negative 4, well, we're going to bring out a 4 in front, and then the new power in here would be negative 4 minus 1, which is negative 5, right? And because we have 2 negatives in here, so that will make a positive. So we're going to get 1 and then plus. And then the 4 in here has nothing to do with the negative exponent, but the x does. So then we're going to throw the x onto the bottom and then return the negative 1 to a positive 5. And return a -5 to a +5. There we go. And then this one is the final answer. Okay? And let me take some of these work out the page so we get like more space in here to do it. Okay, last one, let me put it in brown, I guess. Okay, so as you notice, we have like also 3 things in here for the last part. That means that we're gonna have to set each of them with the derivative. So we have 4x derivative and then minus because it says so, and then 7 over x to the 4th derivative, and then plus 5 derivative, right? And right off the bat, again, this one is 0, so we don't even have to worry about it. Okay, this one in here, we're gonna have to like set aside the number, and then we're gonna focus on taking the derivative of the constant, the variable part. Same goes with the second one. We're gonna have to rewrite it and then put out the number or whatever constant you have in there. So it's gonna look like this, and then we focus on taking the derivative of that variable. So now derivative of x is just 1, so that means we're gonna get like 4 times 1. Derivative of x to the -4 in here would be -4 times x to the -5. So putting everything together, we're gonna get 4 in here, and then plus 28 over x to the 5th power. Okay, and this is my 5, my ugly 5, so let me try to rewrite it in a nicer way. There we go. Okay, so that's everything on for like, the part A. As for part B, what do we get in here? Find the slopes of the graph of the following functions where x equals to -2, 0, and 2. Okay, so we have to find the slope of like 3 x values in here, okay? But first of all, how can we find the slope, right? I told you that from 2.1 to find the slope, we have to take the derivative of the function, right? So let me go ahead and do it really quick. But before that, let me take care of everything on this page. Now it's clean. Okay, let me put it back to red. Okay, so how can we take the derivative of f? Well, same deal, right? We're gonna split them out into 3 parts in here. So x5 derivative, and then minus 1x7 derivative, and then plus 100 derivative, right? And then this is gone because 100 in here, again, is a number. X to the 5th power, the derivative of it will be 5x4. 1 over x to the 7. Well, we don't know what that is, so we have to rewrite it as x to the -7 derivative. And then after that, we're gonna keep the 5x4 because like we don't do anything to it yet. But then the derivative of x to the -7, it equals to -7, and then x to the -8, right? So at the end, that equals to 5x4. And then we have like a positive in here, and then 7 over x to the 8th power. Okay, so this is like the slope formula right here. So now we have to do 3 values for x, right? So let me put the -2 case in pink. So just imagine if we plug in -2 for x in here. What are we gonna get? We're gonna get like 5 times -2 to the 4th power plus 7 divided by -2 to the 8th power. And if you put everything to the calculator, you're gonna get something like 2487 divided by 256. Okay? And then similarly, let me put the case of 0 in, blue. Okay, let me write up here too. So we're gonna get f prime of 0. What we're gonna do, we're gonna plug that into this formula right here again. So that gives us something like 5 and then times 0 to the 4th power, and then plus 7 divided by 0 to the 8th power, right? The first one is like 0 in here, but then the second one, we have a 0 on the bottom. This is not good, right? So this is like undefined, or like D and E doesn't exist, right? So at the end, the answer in here would be just D and E. Because like 0 plus D and E, like this doesn't mean anything at all, right? So it's just gonna be D and E. Okay, and this one, let me just box it before I keep going. Okay, so what does it mean to have a D and E in here? It means that at the value of x equal to 0, we don't have any slope, okay? We're gonna have something we call an asymptote in here. But you guys don't have to worry about that now. Just know for the fact that we're not gonna have any slope at the point x equal to 0. Okay, that's what it means for, you know, like doesn't exist. Okay, and as for the last part, let me put in, I don't know, like brow. For 2, well, we're gonna do the same procedure again, right? We're gonna do like f prime of 2, and again we're gonna plug the 2 into this formula right here. So we're gonna get 5 and then times 2 to the 4th power, and then plus 7 and then 2 to the 8th power, and that gives me the same number as before, 20 and then 487 divided by 256, and this is the slope for, you know, x equal to 2. Okay, so all the answers in here. So remember, for part B, there's 4 things to do, right? First of all, you have to find the slope of the graph, which is the derivative, by using all the rules that we had before. Second part, we have to plug in like different values for x in here, and then from there we're gonna get different slope at different like x. Okay, and let me put a green star for your part. Like, you're gonna have to do all these and also like this one in here. Okay, and now let's talk about the last objective of 2.2, application. All right, so because we're business major in here, so we have to know how to apply like what we learned into, you know, like business, right? Like real life situation. But keep in mind that like this section is all about like derivative, right? So whenever you have a function in here, especially for like 2.2, well, obviously you always have to take the derivative first, right? So with that saying in here, let's do my part first. The sales S in millions of dollars per year for that company from 1999 through 2005 can be modeled by this equation right here. I'm not gonna read out that equation, but we have that equation there. Okay, where t is a year. T in here, t equals to 9, corresponding to 1999, right? And then we have to find the slope of the graph at the year 2001. Okay, so what is the t value for the year 2001, right? So if 9 equals to, you know, like 1999, then what happens for the year of 2000, and then what happens for the year, you know, like 2001, right? This one is just like 1 up, right? So that means t in here equals to 10, and that means that at the year of 2001 we're gonna get t equal to 11. Okay, and I mean, if you're like lazy, if you don't want to do it that way, well, you can just find a difference between 2001 and 1999. If you put into the calculator 2001 minus 1999, you're gonna get a 2, right? And on top of that, you have like a 9 to start with. So 2 plus 9, you're gonna end up with 11 in here. Okay, so that's like 2 ways to figure out the t value in there. Okay, and now let me take this out the page. And because the problem is asking us for the slope of the graph, right? So you know what to do. We have to find s prime. Let me move this one away first because it's just taking too much space. Okay, so keep in mind, like earlier, that in 2001, the t value here is 11. Okay, so just keep that in mind, so that we can plug in 11 later on. Okay, but for now, let's find the derivative of this. So we all know that we're gonna like chop them out into like terms, and we're gonna take the derivative of each of them like this, right? And of course, because the last one is like a constant, so that's gone. It's going to be like 0, right? All right, so that's like the first step. Next step in here, for the first one, we're gonna put away the number. We're gonna separate all the numbers away from the variable. So we're gonna get like t to the 4th in here, and then derivative, and then plus 7t, and then t to the 3rd power in here, derivative, and then negative 1364, and then t squared, derivative, and then lastly we're gonna get 11511, and then t derivative. But then if you remember, the derivative of t or derivative of x is just 1. Okay, and by the way, don't get confused. Just because we are so familiar with using x earlier, it doesn't mean that x cannot be not a variable, right? So in this case, for example, the x in here doesn't say a lot about like time. That's why we stick with the variable t, but t in here is the same thing as x. Okay, so if you're not comfortable with like using another variable, I will suggest replacing everywhere that has like t with x from the problem, so then it doesn't confuse you. Okay, so anyways, Okay, this one I'm gonna do it really quick. So the number is there, and then the derivative of this one is 4t cubed. And then the number in here is 70. The derivative in here is 3t squared. And then 1364, derivative of this one would be 2t. Right? And then the last one, I already take the derivative of it. So it's just going to be like a number like this. Okay? And then I'm going to go ahead and multiply everything together. So I'm going to get something like negative 5.16 t cubed plus 210 t squared, and then minus 2728 t, and then plus 11511. Okay, last step, because we know that we have to find the slope at the point t equals to 11, so we're going to plug in t equals to 11 to this formula right here, right? So I'm too lazy to write it down, but technically wherever you have t in here, plug in 11, okay? And then if you do like correctly into the calculator, you're gonna get the result of 55.04. Okay, so what does it mean, right? The slope in here, it tells us that at the end of year 2001, the sales for the company that we're talking about was increasing at the rate of $45.04 millions per year. Okay. And this one is like the graph to show us that, you know, like at the time where t equals to 11, we're going to get a positive slope in there. That's why this number in here is positive, right? It's why it's like, you know, like 45 is increasing. And we're talking about the year of like 2001, right? So at the end of the year 2001, again, the sales of the company that we're talking about was increasing by $45.04 millions. Okay, million in shortcut per year. Okay, so these are like the meaning for it, like for this number in here. Okay, and for your part, you're gonna have this problem in here, right? So again, it's pretty simple. We have the equation already, so you just have to find the derivative of r in here. And after that, it's asking you for the year 2003, right? So make sure you get the right t value for 2003, and then just plug it in, and then you get the answer. Okay. If you have a problem of, you know, like interpreting it, let me know. Else, you good with it. And if you notice, you should get like a positive number, right? Because as you can see, the line here is going up, right? So it should be something increasing. It cannot be negative because we don't have like any falling line in here. Okay. So that's it for 2.2. And if you have any questions, let me know. Okay. Thank you for your listening. Take care and have a great day. Bye bye.